Hello everyone, you're welcome to my class. Today we're going to practice UTME past question using test driller UTME uh, software. So this is perfect for you since you are preparing for these CBT examinations. So this is an updated version of it. So here we are. I'm going to practice. So we select the subject. Here I want to practice physics. So select physics, then okay. So you can choose the year. So let's go for 2025. Make our question 10 and all topics. So you can decide not to reshuffle as the case may be. You can increase your time or decrease the time. So then you start. As simple as that. So here is our question. So the first question says, what is the phenomenon where a wave changes direction as it passes from one medium to another? So what do you think is the answer? Okay, so we have reflection, we have refraction, we have diffraction, and interference. So the correct answer here is a refraction. So reflection is the bouncing back of wave when it hits a plane surface, right? Either plane surface or rough surfaces. So that will give you the two types of reflection, which is the rough and smooth, right? So reflection. Refraction is when a wave changes direction from one medium to another, right? When a wave passes from one medium to another, it changes direction due to a difference in density, right? And diffraction is the phenomenon of wave bending around an obstacle, while interference is when two wave, superimpose, right? So have interference. So the correct answer here is option B. Remember that we solve and also explain the reason behind our answer. Is that understood? So that is about this particular question. So the next one, question two says, a balloon contains 110 centimeter cube of air at this temperature and 760 mm of mercury. If the balloon is released and rises to an altitude where the temperature is negative 23 degrees Celsius and the pressure is 380 mm of mercury, a millimeter of mercury, what will be its new volume? Assume ideal gas behavior. So for ideal gas behavior, we have that PV is equal to nRT. Is that correct? So this taken to be a constant. So we have PV all over T equal to constant. Is that clear? So if this is understood, here is V, please. So if this is understood, let us itemize what we are given. Here are the initial conditions. So we call this one V1. Here is T1, and here is P1. Is that understood? So those are the initial conditions. So the rest, here is the second condition, the final condition. We have T2, and we have here to be P2. Then you're looking for V2. So take note of this. You need to be smart in your exam. You understood? You need to be smart, very smart. So from here, from this formula or relation, I can just have P1, V1 all over T1 equal to P2, V2 all over T2. So since I'm looking for V2, I'll make V2 subject to the formula by cross multiplying. Quickly, you cross multiply. You have what? P1 V1 multiplied by T2 all divided by P2 P2 T1. You are crossing multiply like this. You need to be smart, right? So from here, that is equal to V2. So we can now say V2 is equal to, what is our P1? P1, I've already itemized it here. P1 is 760 multiplied by V1 V1 is said to be 10,000 centimeter cube, 10,000 centimeter cube, and here is T2. T2 is given in degrees Celsius, so you convert it to Kelvin. So T2 is negative 23, that is 23 plus 273. That will give us 250 Kelvin. And T1 was given to be what? To be 27 degrees Celsius. That will be 27 plus 273 to Kelvin. That will give us 300 Kelvin. Is that understood? So our T2 is 250 Kelvin, all divided by P2. What is P2? That is 380, already shown it here, 380 multiplied by T1, which is 300. So quickly press your calculator, right? You have, if you multiply this, you're going to have 1.9 exponential 9, all divided by, multiply this by this, you are going to have 11,400. Quickly divide. If you do that, you have 16,666.67 centimeter cube. That will give us a option D. Question 3 says, a 3-volt cell drives 0.5 amp through a circuit. If the internal resistance is this, what is the resistance of the external circuit? So in exam, in a JAMB work or exam, nobody asks you to draw a circuit, but for a better understanding, so I'll draw this simple circuit here. The cells have the EMF of 3 volt and internal resistance of 1 ohms, right? It drives a current I of 0.5 amp through an external resistance R. So you're asked to calculate the resistance of the external resistance. We're looking for the R here. Is that understood? So we have the EMF of the cell to be this. But for us to get R, right, we need the terminal voltage, capital letter V. It is not given. Is that understood? Remember your Ohm's law that V is equal to IR. So I have I don't have R, I don't have V. How do I get V? In every cell, the EMF is the sum of the terminal voltage and the lost voltage. So your terminal voltage is equal to EMF is equal to terminal voltage, and lost voltage this time around is I, the current multiplied by the internal resistance. Is that understood? So from here, I can have my terminal voltage to be equal to the EMF minus what? Minus the lost voltage. So my EMF is what? My EMF is 3 minus I is 0.5 multiplied by 1. That will be equal to 3 minus 0.5, which is equal to what? 2.5 volts. So having gotten my terminal voltage to be 2.5 volts, then I can now apply my V equal to IR, such that R will be equal to V all over I. So when you do that, you're going to have your V, which is 2.5, all over I, which is 0.5. Press your calculator, you should have 5 ohms. I hope this is understood. So this is about this question. So in an exam settings, you don't need to draw this diagram. No, all you need to do is to understand you are giving your EMF, right? So don't take this as the EMF. They said a 3-volt cells. So they're talking about the EMF. Don't take it as the potential difference, right? Or terminal voltage. So you take it as the value of the EMF of the battery, right? Right? Okay. So that when you get that, you remember that your EMF is the sum of the terminal voltage and the lost voltage. How do you get your lost voltage? Multiply the current by the internal resistance to give you your lost voltage. And the difference between the EMF and the lost voltage will give you the terminal voltage. When you get your terminal voltage, you use it to calculate your external resistance. Is that understood? So that is about question 3. So question 4 says, a 2 kg block of a metal alloy with a specific heat capacity of 400 joule per kilogram per degree Celsius is heated by 500 watt heater for 2 minutes. Assuming no heat loss to the surrounding, what is the final temperature of the block if its initial temperature was 20 degrees Celsius? Quickly, without wasting our time, this is under specific capacity and what? The electrical method of finding the specific capacity of material, of solid material. Is that correct? So that is about that. So the heat energy lost by the heating element, that is the heat energy, PT, power multiplied by time, is equal to the heat gained by the solid material, which is MC, change in theta. So we can also write it as MC, change in theta is equal to PT. All is correct. So you can write it to be MC, change in theta become theta 2 minus theta 1, which is equal to PT. So in exam setting, you can quickly decide to itemize quickly in order for you to know what you are doing. M is equal to 2 kilogram. Is that correct? And the C specific capacity is 400, right? Joule per kilogram per degree Celsius. And the power, right, is 500 watt, right? And the time T is said to be 2 minutes. So 2 minutes to second, always convert to second. That will give us 2 multiplied by 60, which is equal to 120 seconds. Is that understood? So if this is taken, quickly you have done this and you're looking for, they said you should look for final temperature, that is T2. So that is what we are looking for, given that T1 is equal to 20 degrees Celsius. So I will not convert. Why? Because here my specific capacity is in degrees Celsius. So I will not convert to Kelvin. So please take note, especially when you're doing calculations that involve heat capacity or latent heat of fusion, always look out for this particular constant, right? If the unit are in gram, you can decide to leave it in gram or convert. But if it is in kilogram, you leave it the way it is. And if this one is in degrees Celsius and you're looking for temperature, don't bother to convert. Is that understood? When you have done this one quickly come back and substitute your value. M is what? 2 multiplied by C, 400, open bracket, T2 that you are looking for, minus what? 20 equal to P, which is 500, then multiplied by T, which is 120. So from here, you can have your T2 minus 20 is equal to 500 multiplied by 120 all over 2 multiplied by 400. Sometimes it is good for you to separate your work like this. You should not go and multiply 500 by 120. You have big value, then you don't know what to do. But as you separate like this, you'll be able to quickly cancel each other. Let this one go with this. Then we have 2 here, 1. Okay, 2 here, 1, 2 here. Can have 2 here, 6. Is that understood? So we can have theta 2 minus 20 equal to 5 multiplied by 60 all over what? All over 4. So I can still say 2 here, 1, 2 here, 3. I can still say 2 here, 1, 2 here, 15. That will give us 5 multiplied by 15, which is equal to 75. This implies that theta 2 minus 20 is equal to 75. Therefore, theta 2 is 75 plus 20 to give us 95 degrees Celsius. Is this understood? I don't know if I'm rushing, it's an exam setting. You understand? So you need to be very smart, fast, with accuracy. Is that understood? So if there's anyone you don't understand, just pause, go back. I believe you're going to understand the steps I took. So that is about question number Number 4, if I'm rushing, you can just let me know in the comment section, so I'll take care of that. So let's look at question 5. So question 5 says, which of the following statement about wave is true? Which of the following statement about wave is true? A, waves cannot transfer energy. No, wave is said to be a disturbance that transfers energy from one point to another without causing any permanent displacement of the system itself, right? So that is it's not true. They are looking for the one that is true. Number B said, waves require a medium to travel, though not all waves require material medium, so it is partially correct. C, all waves are transverse, not all waves are transverse wave. D, wave transfer energy without transferring matter. That is correct, option D. Wave transfer energy without transferring matter. That is the correct option. I hope we are together. So moving on to question number 6. Question 6 says, a car is traveling at 90 km/h. The driver sees a hazard and applies the brakes, decelerating at a rate of 5 meters per second squared. What is the distance the car travels before coming to rest? Since the car comes to rest, so our final velocity will be equal to 0 meters per second. Take note, the car comes to rest. So since the car is traveling at, that is our initial velocity, u is equal to what? 90 km/h. Do we need to convert? Yes, because our options are in meter. Quickly convert. That will give us 90 multiplied by 1,000 all divided by 3,600. So when you do this, you should have 25 meters per second. You have 25 meters per second as your initial velocity, you have your final velocity, and you have your deceleration, which is a negative of acceleration. So it's going to be minus 5 meters per second squared. So you're looking for the distance s, you don't know. So among your 3 equations of motion, which one do you think you can apply? Please make sure you know this. V equal to u plus at. Another one, v squared is equal to u squared plus 2as. Another one is s is equal to ut plus a half at squared. Another one is s is equal to u plus v all over 2 all multiplied by t. Is that understood? Now, looking at what we have here, which do you think is appropriate for this problem? Right? Here, we have t, and in all these parameters given to us, we don't have t. Is that correct? And again, that is to say this one cannot go. So the second equation, we have v, we have u, we have a, we have s. I think it can go. Let's look at s2. Can it go? We have t, we don't have t in our parameters, therefore it cannot go. Also, we have t here. T is not in our parameters, so it cannot go quickly. In the exam setting, you can write them down somewhere and see which one that will be okay for you. Or if you can use your head, you can quickly tell that, okay, the best option here is a v square equal to u square plus 2as. Is that understood? Remember, I said you need to be smart. So v equal to 0, and u is what? Is 25. You square it, right? Plus 2 multiplied by a is negative because it is deceleration multiplied by s. So quickly, this implies 0 equal to 25 squared. That will give us a 625. 625 minus 10 multiplied by s. I hope we are together. So when this one crosses this equality sign, it turns to minus 625 equal to minus 10s. So negative, we cancel negative. I have s to be equal to 625 all divided by 10. That will give us 2.5 meters. So the correct option here is what? Is option C. I hope we are all together. So it's option C. So that is about question number 6. So let's look at question 7. Question 7 says, the phenomenon by which sound waves bend round obstacle is called, I believe you should know this answer because while treating number 2 or thereabout, I think number 1, I have already trashed this particular one. So the correct answer here is a diffraction. That is question number 7. So question number 8 says, a 10 ohm resistor carries a current of 2 amp. What is the power dissipated? So as a physics student, you should know the 3 formula that relate power, the resistor, the current, and the potential difference. We have that P is equal to IV, right? Okay, power for IV, invitation card, right? So you don't have invitation card, you don't have power to attend occasion. So take note of this particular one. It's very simple to remember. P equal to IV. So from here we get order because V is equal to IR according to what? Ohm's law. So anywhere I see V in this P equal to IV, I'll put what? IR. That will give us P equal to I square R. That is second equation. Also, if I make I subject to the formula, V over R, so that in this equation also, anywhere I see I, I'll put what? V over R multiplied by V, that will give us what? V squared all over R. So we can now conclude that we have how many formulas? We have three formulas, P equal to IV, P equal to I square R, and P equal to V squared all over R. So from what we have here, we are given that R is equal to 10 ohms and the current I is equal to 2 amps. Then we are looking for power dissipated. So which formula do you think is appropriate for this particular question? We have I and R, therefore this is the appropriate formula. So quickly use P equal to what? I squared R. That will be equal to, what is my I? 2 squared multiplied by R, which is 10. That will give us what? 4 multiplied by 10, which is equal to 40 watt. So that is option what? That is option B. I hope this is understood. So moving on, we move to question number 9. Question number 9 says, a crane lifts a 1000 kg crate from the ground to a height of 15 meters in 30 seconds. What is the average power of the crane, given that G is 9.8 meter per second squared, right? Okay. So from here, quickly, you should know what you need to apply here. Looking for power. So we are giving time, we are giving this, we are giving that. So you should know power is equal to the rate of doing work, right? That is work done all over time. This time around, work done is not done in the horizontal direction, rather it is work done on this particular crate against gravity. And in that case, work done will be equal to mgh, then all over time. Please take note of this formula. Is that clear? If it had been a horizontal, it would be force multiplied by the horizontal distance. Is that clear? So, but now it is against gravity. So it can also be done by gravity, which is still mgh, as the case may be. So here you're going to have your mass set to be 1000 multiplied by 9.8, right? Then multiplied by height, which is 15 meter, all over 30 seconds. Are we together? So when you multiply the upper one, you're going to have 147,000 all over 30. Then if you divide, that will give us 4,900. 4,900 watt. If you take it to kilowatt, that will give us 4.9 kilowatt. So please, one thing I want you to notice in this particular question, many people can fail, many candidates can fail this question. You know why? Because most of us are used to using G to be equal to 10 meter per second squared. But this time around, they say you should take it as 9.8. If you take it as 10, you're going to have this as your answer. But if you take it as 9.8 as the question demands, you're going to have this to be your answer. So this time around, this one is wrong. This is the correct one. Please take note of this particular instance. So you have to be very, 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 pay attention to every details. Is that understood? So that is about question number 9. Quickly move to question number 10. Question number 10 says, a rocket moves in space by expelling gas, right? This motion is best explained by A, Newton's first law, Newton's second law, Newton's third law. This one is Jara for you. I think you should know that is Newton's third law. Action and reaction are equal what? Opposite. So we have a rocket, right? So a rocket is expelling gas. So this is what? Action. So the reaction is that it is moving the rocket forward, right? So that's going to be reaction. So according to third law, action and reaction are equal but opposite. So this is the direction of the expulsion of the gas, and this is the direction of what? Of the rocket. I hope this is understood. So we are going to stop here in today's class and continue from here in our next class. Thank you for your time. I hope you enjoyed the class. See you in the next class.